7,000 miles per hour faster than a bullet, and still it is dying. Somewhere past the edge of everything we call home, a machine older than the internet, older than cell phones, older than most of the people reading this sentence, is running out of heartbeat. And NASA just made a decision that tells you everything about how serious this has become. They didn't upgrade it. They didn't repair it. They shut a piece of it off. On purpose. Because keeping Voyager 1 alive now means choosing which parts of it get to die first. Let that sink in for a second. This is not a machine breaking down by accident. This is a controlled, deliberate, engineered decline. A slow-motion negotiation between human ingenuity and the merciless physics of deep space. And the closer you look at what's actually happening out there right now in the summer of 2026, the more it stops looking like routine maintenance and starts looking like something else entirely. A countdown. Here's what most people don't realize. Voyager 1 isn't just far away. It is farther away than any human-made object has ever been, farther than anything we have ever built has traveled in the history of our species. Launched in September of 1977 when Jimmy Carter was in the White House and computers filled entire rooms, this spacecraft was never supposed to still be talking to us. Its original mission was 5 years. Fly past Jupiter, fly past Saturn, take some pictures. Come home, metaphorically speaking, having done its job. But here's where it gets worse, or better, depending on how you look at it. Voyager 1 didn't stop. It used the gravity of Jupiter and Saturn like a slingshot, flinging itself up and out of the flat plane where all the planets orbit, onto a permanent one-way trajectory into deep space. It never looked back. It never adjusted course. In fact, it hasn't fired a trajectory correction since 1980, nearly half a century of coasting on momentum alone, dictated entirely by physics set in motion during a handful of planetary flybys back when disco was still playing on the radio. Think about what that means. Every second of every day since 1980, this spacecraft has been flying blind, on a path locked in decades ago, through territory no human engineer designed it to survive in, and it kept going. In August of 2012, after 35 years of continuous flight, Voyager 1 crossed something scientists call the heliopause, the outer edge of the sun's protective bubble, the invisible boundary where the solar wind finally gives up, and the true emptiness of interstellar space begins. It became the first human-made object to leave our solar system's protective shell entirely. Not orbit it, not approach it, leave it. And this is where everything changes, because leaving the safety of the sun's bubble is not something you do and then come home from. Voyager 1 is now traveling through the space between stars, in territory so alien, so radiation-soaked, so devoid of the shielding our sun normally provides that scientists still don't fully understand everything it's flying through. It is, right now, the only functioning instrument humanity has ever placed in that environment for this long. There is no backup. There is no second chance. If it goes silent, that specific vantage point on the universe goes silent with it, possibly forever. But here's the part that should actually worry you. It's dying. Not metaphorically, literally, physically, running out of power, 1 watt at a time. Voyager 1 runs on something called a radioisotope thermoelectric generator, essentially a chunk of decaying plutonium that converts heat into electricity as it slowly breaks down. It's an elegant piece of 1970s engineering, brilliant for its time, built to outlast anything anyone thought possible. But radioactive decay doesn't negotiate, doesn't pause, doesn't wait for good news. Every single year, without exception, Voyager 1 loses about 4 watts of power. 4 watts. That's less power than a household light bulb. And yet, that tiny, relentless drain is now the single biggest threat to the most historically significant machine humanity has ever built. According to informed reporting from NASA's own mission engineers, this slow bleed has forced the Voyager team into what can only be described as a high-stakes triage operation, conducted from a control room on Earth, aimed at a patient they can't touch, can't see, and can only speak to with a 23-hour delay in each direction. Read that again. 23 hours, one way. If something goes wrong on Voyager 1 right now, at this exact moment, the team on Earth won't even know about it until almost a full day later. And if they send a command to fix it, they won't know if that command worked for nearly 2 full days after the problem first occurred. This is the real story that most coverage of Voyager 1 completely glosses over. It's not just an old spacecraft slowly running out of battery. It's a life support decision being made in near total darkness, at the edge of human capability, with a communication lag so severe that by the time you know there's an emergency, the emergency has already been over for the better part of a day. And in February of this year, that exact nightmare scenario started to unfold. During what should have been a routine, pre-planned roll maneuver, something the spacecraft has done countless times over its lifetime without incident, Voyager 1's power levels suddenly and unexpectedly dropped. Not catastrophically, not fatally, but enough to trigger alarm bells 15 billion miles away, because the mission team knew exactly what was coming next if they didn't act. Any further drop, Even a small one could trigger the spacecraft's built-in undervoltage fault protection system, an automated safeguard designed to shut components down on its own the instant it senses danger, whether the humans back on Earth approve or not. Think about what that means for a machine this old, this far away, this irreplaceable. If the fault protection system kicks in on its own, the spacecraft essentially goes into self-preservation mode without asking permission. And the recovery process that follows is lengthy, delicate, and carries its own serious risks of making things worse. Engineers don't get to walk over and check the wiring. They send a command, they wait nearly 2 days for confirmation, and they hope. So the Voyager team did something you rarely hear describe this bluntly in official statements. They decided to act first before the crisis could force their hand. They chose to shut down one of Voyager 1's remaining science instruments themselves, deliberately, in a calculated act of controlled sacrifice, rather than risk losing control of the spacecraft entirely to an automated system with no judgment and no mercy. On April 17th of this year, mission engineers at NASA's Jet Propulsion Laboratory sent the command. The target was an instrument called the Low Energy Charged Particles Experiment, the LECP for short, a piece of hardware that had operated almost continuously since Voyager 1 launched in 1977. 49 years without interruption. It had measured cosmic rays, tracked ions and electrons streaming in from both our solar system and the deeper galaxy beyond, and helped scientists identify pressure fronts and density changes in the mysterious region beyond the heliosphere. It was, in the words of the mission's own principal investigator, instrumental in helping humanity sense the exact moment Voyager crossed from our solar system into true interstellar space. And now it's gone dark. Not because it broke, because it had to be sacrificed to keep the rest of the spacecraft alive. While shutting down a science instrument is not anybody's preference, it is the best option available, said Kareem Badruddin, the Voyager mission manager at JPL, in a statement that reads, less like a technical update and more like a battlefield commander explaining a hard call. Voyager postatioma. One still has 2 operating science instruments left, one listening to plasma waves, one measuring magnetic fields. That's it. 2 instruments, functioning at the far edge of human reach, are all that remain of what was once a 10-instrument scientific powerhouse. This is not chaos, this is strategy, and it's a strategy that was decided years in advance. Here's what most people are not seeing. This wasn't a panicked, last-minute decision made in a crisis. Years ago, the Voyager science and engineering teams sat down and mapped out, in advance, the exact order in which they would shut down parts of the spacecraft as power continued to fail, a pre-written triage list for a slow-motion emergency they knew was coming decades before it arrived. Of the original 10 identical sets of instruments carried by Voyager 1, 7 have now been shut off. The LECP was simply next in line, a casualty scheduled long before the actual moment of sacrifice arrived. Its twin instrument on Voyager 2 was shut down back in March of 2025, following the exact same playbook. And because Voyager 1 is now more than 15 billion miles from Earth, even the shutdown itself became an exercise in extreme patience. The command took roughly 23 hours just to reach the spacecraft. The shutdown process itself, once received, took another 3 hours and 15 minutes to complete. Somewhere in the vast dark between stars, a signal from Earth crawled across billions of miles to tell a 49-year-old machine to quietly turn off a piece of itself. And by the time that command was received, the humans who sent it had already gone to sleep, woken up, and gone back to work, still not knowing for certain whether it had worked at all. But here's where the story stops being just about survival and starts becoming something closer to a gamble. Because the mission team isn't simply managing decline, they're fighting back. Engineers have developed a bold, high-risk plan, one that's been given the almost theatrically dramatic internal nickname, the Big Bang, designed not just to slow the spacecraft's death, but to potentially reverse part of it. The idea is audacious. If it works, it could free up enough power to actually turn the LECP instrument back on, resurrecting a piece of the spacecraft that engineers had just sacrificed. Think about the sheer nerve of that. You don't get many second chances 15 billion miles from Earth. And yet, here's a team of engineers, decades into a mission that was supposed to end in the early 1980s, attempting something audacious enough to earn a nickname referencing the origin of the universe itself. The plan is being tested first on Voyager 2, which has slightly more available power and a marginally shorter communication delay, making it the lower risk candidate for the experiment. Tests were scheduled for May and June of this year. And if that maneuver succeeds on Voyager 2, the team plans to attempt the exact same fix on Voyager 1 no earlier than July, this month. Right now, as this is being written, that attempt may already be underway, 15 billion miles away, its outcome still unknown to anyone on Earth for nearly 2 full days after it happens. Matt Hill, the principal investigator for the LECP instrument at Johns Hopkins Applied Physics Laboratory, put it in terms that sound less like science and more like hope whispered into the dark. He said the team is holding out for the possibility that this latest plan could power the instrument back up, letting scientists continue learning whatever surprises await Voyager in these distant regions of space. And then he added something that should give you chills. The engineers have a track record of performing what looks like miracles to stretch the spacecraft's remaining power. But eventually, he said, that streak will end. Not if, when. And this is the part of the story that turns a technical update into something almost unbearably human. Because even as engineers fight this rearguard action against entropy, the spacecraft itself is racing toward a milestone that sounds almost like science fiction. In November of this year, Voyager 1 will become the first human-made object in history to reach a full light day from Earth, a distance of roughly 25.9 billion kilometers, so vast that a radio signal traveling at the literal speed of light needs a full 24 hours just to cross it. According to Susie Dodd, the Voyager project manager at NASA's Jet Propulsion Laboratory, if engineers send a command at 8 in the morning on a Monday, they won't receive Voyager 1's response until 8 in the morning on Wednesday. 2 full days, round trip, for a single question and a single answer. Right now, at this very moment, Voyager 1 sits roughly 15.8 billion miles from Earth, with a one-way signal delay already stretching to nearly 24 hours. By the time it crosses the light day threshold later this year, the gap between question and answer will have grown so vast that having a real-time conversation with humanity's most distant machine will be, for all practical purposes, physically impossible. So picture this. A spacecraft is racing toward the most extreme communication distance ever achieved by any human technology. At the exact same moment, its power supply is collapsing toward zero. 2 separate countdowns, both driven by unstoppable physics, both converging on the same fragile point of failure. A 49-year-old machine, built with less computing power than a modern digital watch, trying to outlast both the dark and the silence at the same time. And here's the truth nobody wants to say out loud in a press release. This ends. NASA's own engineers project that sometime in the 2030s, Voyager 1 will finally lose enough power that its remaining instruments can no longer function. When that threshold is crossed, the spacecraft will go permanently, irreversibly silent. No dramatic explosion, no final transmission, just a quiet cutoff, somewhere in the freezing dark between the stars, after which humanity will never hear from it again. But, and this is the detail almost nobody talks about, its physical journey won't stop just because its voice does. Even after it goes silent, Voyager 1 will keep moving forever, carried by momentum alone through territory with no atmosphere to slow it, no gravity strong enough to pull it back. In roughly 300 years, still coasting in total silence, it will reach the inner edge of the Oort cloud, the vast, distant shell of icy debris that marks the true outer boundary of our solar system. And it won't even finish crossing that region for another 30,000 years after that. Sit with that for a moment. A machine we will lose contact with sometime in the next decade will still be flying, silently, mindlessly, faithfully, for tens of thousands of years afterward. Long after every person who ever worked on this mission, and every person reading this sentence right now is gone. It carries with it a golden record, a phonograph disc etched with images of Earth, greetings in 55 languages, and 90 minutes of music, all curated under the direction of Carl Sagan, meant as an introduction to any civilization that might one day intercept it in a future none of us will live to see. This is the part most explanations skip entirely. Voyager 1 isn't just a scientific instrument. It's a message in a bottle thrown into an ocean so vast that even light itself needs a full day just to reach the shoreline where it currently floats. And what most people are not seeing is that we are watching the final chapter of that story unfold in real time, right now, in the middle of 2226. A slow, deliberate, engineered ending being managed one sacrificed instrument at a time by a small team of engineers who refuse to let it go quietly without a fight. So here is where this leaves us. Sometime this month, possibly this very week, an experimental power-saving maneuver nicknamed after the birth of the universe is being attempted on a machine older than most of the people managing it, in an environment more hostile and more distant than anywhere humanity has ever sent a working device before. If it succeeds, a piece of Voyager 1 that we thought was gone for good might flicker back to life, if only for a little while longer. If it fails, that sacrifice becomes permanent, and the countdown toward total silence accelerates. Either way, the clock is already running. Later this year, Voyager 1 will cross a distance so extreme that talking to it in anything resembling real time will become physically impossible. Sometime in the next decade, its last instruments will finally go dark for good. And after that, it will simply keep going, alone, silent, carrying humanity's message further into a darkness we will never see the end of. We built something that outlived our expectations, outlived the political era that launched it, outlived most of the engineers who first turned it on. And now, 15 billion miles from home, it is quietly, deliberately, heroically dying. On its own terms, for as long as we can possibly help it hold on. The only question left is how much longer we get to listen before the silence becomes permanent. And whether somewhere in that 300-year drift toward the edge of everything we know, Voyager 1 is still carrying something out there that we haven't even thought to ask about yet.